In today's video, we're going to be looking at how to solve problems with rational numbers. So these are going to be word problems and application problems where you'll have to apply the skills that you've already learned on how to operate with rational numbers. So just to review, before we dig into actual word problems, it's good to look over some words that are kind of like keywords to help us figure out what sort of operations we're going to need to use. So when you see words that are listed under this column, it's going to mean we're going to add. And we're going to add a couple more to that list. So obviously plus is one that we'll hear a lot. Another one would be sum. That is the answer to an addition problem. So the sum of two numbers just adds them together. And then total. So the total of your bill at the grocery store is all of your items added together. So you're adding those things up. So the rest of these words are other things you'll be hearing. Ascended means to go up. So sometimes when we're talking about like a hiker ascending a mountain, they're going up the mountain. So you could maybe draw an arrow of going up. And then the rest are kind of ones that you've probably already seen before. Moving into subtraction, we always hear minus. That's how we say a subtraction problem. Another word we could use would be difference. So that's the answer to a subtraction problem. So it's like how we had the word sum for addition. The difference of two numbers is when you subtract them. Other words that we could use are reduced by, and then the ones that were already listed. So descended is just the opposite of ascended. So you could think of a hiker descending a mountain. So they'd be walking back down. So that distance would be negative because they're moving down the mountain. The rest are probably ones that you've seen before. Just to make a note of more than here and less than, the than with both of those causes the order of those things to switch. So if I have 6 less than 10, that means that I wouldn't write it as 6 minus 10, but I would say 10 minus 6, because 6 less than 10 is 4. We know that. So we'd have to write it as 10 minus 6 to equal 4. So that's just something to take note of. When we multiply, there's some words that are going to tell us we're multiplying. So times is one we hear a lot. Product means you're taking the product of two numbers, you're multiplying them together. So it's kind of like difference and sum. Each, twice, and double. And then another one you'll see a lot in word problems is of. Our last operation is division. So you'll see quotient, and quotient just means you're taking two numbers and dividing them by one another. So it's the answer to a division problem, just like how we had the product, the difference, and the sum. Other words you could see are divided by. You could see per, and you could see split. You could also have ratio of, and remember that ratios can be written as fractions, so that would just remind us that we're putting it into a fraction, which would be dividing. Now that we've reviewed some of those keywords, let's go ahead and practice translating verbal expressions into algebraic expressions. So for this first one, we have 4 increased by 12. So remember, increased is going to come from our addition list. So all that would look like in numbers would be 4 plus 12. 4 is being increased by 12. Our next one says 3 decreased by 9. Decreased means subtract, so 3 minus 9. We have twice 40 is 80. So twice here means 2 times 40. And then we have is. We didn't talk about is, but is just means equal or the same as. So we can say 2 times 40 equals 80. You also could have written that multiplication sign using an x, but I'm going to just avoid using that x here. So then our last one is the quotient of 6. So remember, quotient is division. It's the quotient of 6 and 3 less 1. So we have a few steps here. The first part says the quotient of 6 and 3. So those go together. We're going to take the quotient of 6 and divide it by 3. So 6 divided by 3. And then it says less 1. Less means we subtract, so we're going to subtract 1. So you would first have to divide here and then subtract 1 using the order of operations. Hopefully that was a good review of how to translate. We're going to have to use those keywords as we try to figure out how to solve practical problems. So moving on to the other side of your notes, we have steps for problem solving. So the first thing you want to do with every word problem is read the problem, of course. Don't look at it, get scared of all the words and say, I don't know what to do. Read the problem first. Once you've read the problem, you want to make sense of it to figure out what the question is. So reread the problem, make sure you understand what the question's really asking you to figure out. If you don't understand what the question's asking you to do, of course you're not going to know how to solve it. So try to make sense of what it's telling you and what it wants you to figure out. Another step would be to underline the key words. So words like the ones we just went over. So like when you see ascended, you should underline that and say, well, ascend means add, so I'm going to have to add here. You should also try to cross out information that is not important. So a lot of times in problems, it'll say, maybe an example could be like, at 6 a.m. the temperature was 42 degrees, and at 7 a.m. the temperature was 55 degrees. So really, if the question was trying to figure out what was the temperature change, then you'd only want to know those numbers that were in the temperature, but you wouldn't really care about what the times were. So those 6 a.m. and 7 a.m. times would be irrelevant information in that question. You're also going to want to use your keywords to decide what operation you will need. So again, words like ascended or quotient or the difference of, all of those are going to tell you what operation you're going to need to have to solve this. Once you've decided all those things, you should be able to solve your problem by showing your work. And then the last thing you should do before you circle your answer and move on to the next problem is check your answer and then ask yourself, does this make sense? So if you're asked to figure out what the cost of 2 dozen cupcakes would be, and each cupcake costs $2, you would have to figure out $2 for every cupcake, and if I'm buying 2 dozen, that's 24 cupcakes. So that should be $48. If you get something crazy like $100, think to yourself, would I really spend $100 on 24 cupcakes? It seems a bit pricey. So just make sense of those realistic situations there. So let's try out some of our problem solving steps by doing a couple of these problems together. In our first example, the question reads, the temperature in Madagascar was 60 degrees Fahrenheit on Tuesday and 72 degrees Fahrenheit on Wednesday. What is the difference in temperatures between Tuesday and Wednesday? So it's important that we have the temperature at one time and then another. And then it's also telling us to find the difference. So all the question wants to know is how much did that temperature change from one day to the next. So we know that on one day it was 72 degrees, and then on another day it was 60 degrees. So to find the difference in those temperatures, I'm going to subtract those two. Now the reason I put 72 before 60 is because I wanted to see how much it increased by, because our temperature was at 60 and then it increased to 72. So that means we added some number to that. So I need to subtract 72 minus 60. That gets me 12. So the difference in my temperatures was 12 degrees Fahrenheit. Now just going back and checking to make sure that that makes sense. First of all, we could do a check step mathematically and say, well, I know that 60 plus 12, the temperature that we started with, plus 12, would get me 72. So my temperature increased by 12 degrees. That got me my new temperature. But it also looks like a realistic number to say between 72 and 60, those numbers aren't too far apart from one another, so that number that we got in between shouldn't be too big. Moving on to number 2, the question says that Allie plans to go skydiving over the Grand Canyon. She will drop from the airplane at an altitude of 12,000 feet. She plans to land in the canyon around Bright Angel Campground, where her elevation will be 4,380 feet below sea level. How much distance will Allie cover during her jump? So that's a lot of stuff right there. So we want to find out what's important. That's awesome if she wants to go skydiving, but it's really not going to help us solve the problem. All we know is that when she's up in her airplane, so we could draw a picture, when she's up in her airplane, she's going to drop off at a height of 12,000 feet. So Allie's going to be up in her airplane up here, and then she's going to jump out, and then somewhere down below, we have the Grand Canyon. And she wants to land on this campground, so maybe we'll draw a little tent here. she's going to land around the campground, and that said that she would be at 4,380 feet below sea level. So if it's below sea level, that means that we're talking about a negative 4,380 feet. So this level here, where the Grand Canyon would have started going under, would be considered 0 feet or sea level. This is our neutral level here. So the question then says, how much distance will Allie cover during her jump? So if she's jumping out of the plane all the way up here, her jump's going to go all the way from here, hit sea level, but then she's going to keep going because she wants to land at the campground. So we need to figure out how much is this distance from the sky where she jumps all the way to sea level, plus that distance from sea level to where she's going to land below sea level. So there's two ways to do this problem. We could add these two sections together. We can say, well, this section is 12,000 feet. We know that's how far off the ground she is. Plus, we could add the distance that she covers from when she passes sea level to where she lands. So if we're adding that, that's another 4,380 feet that she's going. So just to add up those two chunks would get us 16,380 feet. Now, the other way we could think about this is we could think about, well, what's the difference between where she began and where she started? So if she started at 12,000 feet, we want to find the difference. Remember, difference means subtract. And we subtract where she ended, which was negative 4,380. Then we have 12,000 minus negative 4,380. So whenever we have a minus minus, remember, we can just turn that into a big plus sign. So then we're essentially just adding like we did up top, and we should get the same number of 16,380 feet. Now, thinking to yourself, does this question make sense? First of all, our answer should not be something smaller than 12,000 feet, because if she doesn't drop at least 12,000 feet, then she hasn't made it back to the ground yet, because her airplane was 12,000 feet above the ground when she jumped out. So our number is larger than 12,000 feet, and we also shouldn't have a negative amount for our answer, because a negative distance doesn't make sense. We can't say Allie dropped negative 16,380 feet, because if she dropped a negative distance, that kind of messes with your head, and how can you follow a negative distance? So just keep that in mind. Our best answer here is the same for both ones, so however you choose to do a problem like this in the future, these are both really good strategies. I always find that drawing a picture for something like this is really helpful for me to make sense of what actually happened. Moving on to number 3. It says a taxi charges $8 per ride plus 35 cents for each mile driven. If Becky needs to go 10 miles, how much money will her taxi cost? So they gave us a lot of info here. They said the taxi charges $8 per ride. So for every ride, you have to pay at least $8. That's your base cost. That's something that we see. And then we know we have plus. So we're going to add that to something for each mile driven. So for every mile that's driven, you're paying 35 cents. So remember the word each we saw in our column for multiplying. So we're going to be multiplying that times the miles. So this is going to get us our cost for the distance. So we're adding the base cost for just getting into the taxi, which is $8, plus 35 cents for every mile you want to go. So in the problem, it tells us that she's going 10 miles. We need to figure out how much money will her taxi cost in all. So we're going to add those two values up once we figure out how much this costs. So we need to figure out, okay, well, for 35 cents for 10 miles, I'm going to multiply 35 cents times 10 miles. If I multiply that by 10, I'm going to get 3.5. But that's not where we're going to stop, because she still hasn't paid her base cost yet. So now we're going to say $8 for her base cost plus $3.50 for the amount of miles that she wants to go. That means when we add those up, we get $11.50. So she's going to spend $11.50 for her 10-mile taxi ride. So that sounds like a reasonable price. If you're going to go only a few miles, you shouldn't have to pay too much money. So that's a pretty reasonable taxi amount. We also shouldn't have any sort of negative amounts here, because the taxi driver wouldn't be paying her. So it sounds like our answer is pretty reasonable here. In number 4, our last question, it says that Kevin is playing a trivia game on his phone. For every correct answer, Kevin earns 2 1/5 points. For every incorrect answer, Kevin earns negative 1/4 of a point. If Kevin has 15 correct answers and 10 incorrect answers, how many points does he have? So again, we get a lot of info. We know that for every correct answer, he's earning positive 2 1/5 points. We also know that he got 15 answers correct. So I'm going to underline those all in one color. And then I'm going to choose a different color for all the incorrect answers. So for incorrect answers, he's getting negative 1/4 of a point, and he has 10 answers that are incorrect. So we need to figure out how many points does he have. So we're looking for his total number of points. So remember, total means we need to add. So we're going to add up all of his correct points plus all of his incorrect points. So it's going to be 2 different steps that we have to solve here. So in order to solve his correct points, for every correct point he gets 2 1/5 point. And we know that we're going to multiply that by the number of times he got a correct answer. So that was 15 correct answers. And then we're going to add that to his incorrect points. For every incorrect answer that Kevin has, he has negative 1/4 points, and he earned 10 incorrect answers. So we're going to multiply that by 10. Now there's a few ways to do this. You can keep the fractions by changing these into improper fractions, or you can just change them to decimals. I think decimals are a little bit easier. So I'm going to rewrite 2 1/5 as 2.2, because remember 1/5 in decimal form is just 0.2. And if I have 2 wholes already, I just have 2.2 when I change that number. I'm going to multiply that by 15, and then I'm going to change my fraction over here. So negative 1/4 is just negative 0.25, because remember that 1/4 or 1/4 is 0.25 or 25 hundredths. And then we multiply that by 10. When we multiply 2.2 by 15, that gets us 33. And then when we multiply negative 25 hundredths times 10, we get negative 250 or 2.5. When we add those two numbers together, whenever you have a positive number and you're adding a negative to it, that's just like subtracting. So this number is going to get a little bit smaller. 33 minus negative 2.5 should get us 30.5 points. So he has 30.5 points total for his game. Now, this makes sense because since he had more answers that were correct than incorrect answers, he should definitely have a positive number of points. If he had gotten every single answer wrong, then his points would be in the negative. But since this number here was higher for correct points, it needs to be a positive answer here. So there are your different steps for problem solving. We can go back to those. They're at the top of your notes here. These are the steps you want to take every single time you try one of these word problems. So read it, make sense of the problem to determine what they're asking you to do, underline keywords, cross out any extra information that we don't need, use your keywords to decide what operation you're going to need, solve your problem, show your work, and then check to make sure your answer makes sense. If you follow these steps each time, you'll be able to figure out these word problems without any issues. Thanks for watching.